So elevation in boiling point delta TB is directly proportional to delta P. So wherein delta P is the lowering vapor pressure. So lowering vapor pressure means P naught minus PS. So then according to dilute solutions, so then delta TB is directly proportional to molality. What is molality of solution? What is molality of solution? It contains non-volatile solute. Molality of solution, it contains non-volatile solute. So then molality means it is a delta TB is directly proportional to molality is small m. So what is molality is small m. So what is molality? So molality equal to the number of moles of solute present in 1 kilogram weight of solvent. So molality means, okay. So molality means the number of moles of solute. So then number of moles of solute, present in 1 kilogram weight of solvent. So now weight of solvent in kilograms. What is weight of solvent in kilograms? So now how to calculate number of moles? Number of moles equal to weight by molecular weight. So then molality M equal to weight of solute by molecular weight of solute into what is 1000 by weight of solvent. What is 1000 by weight of solvent? Okay. So weight of solute by molecular weight of solute into 1000 by weight of solvent. So it is the molality. So now generally what is elevation in boiling point delta TB is directly proportional to M. So now it is the M value. So now removal of proportional, then add the proportionality constant. So then delta TB equal to KB. So it is the molar elevation constant, or it is also known as ebullioscopic constant. So then KB into what is M. Delta TB equal to KB into M. What is KB into M? So wherein KB is the molar, it is the KB is the molar elevation boiling point. Molar elevation, what is a boiling point? Or it is also known as ebullioscopic. What is the ebullioscopic? It is the ebullioscopic constant. What is ebullioscopic constant? Now M equal to weight by gram molecular weight into 1000 by weight of solvent in grams. Okay, weight of solvent in what is grams. Now in the place of molality, to substitute the molality formula. So therefore delta TB equal to KB into weight by gram molecular weight into 1000 by weight of solvent. What is weight of solvent? So now by the using of this formula to calculate the molecular weight of the solute. So then gram molecular weight of the solute. So then gram molecular weight of solute equal to KB into weight into 1000 by delta TB into weight of solvent. What is the weight of solvent? So by using of this formula to calculate the gram molecular weight of solvent. What is the gram molecular weight of solvent? But according to thermodynamical values, what is thermodynamical values? So according to thermodynamical values, so then KB equal to R into TB naught by 1000 into LV. Okay, so then kb equal to R into TB naught by, okay, TB naught by 1000 into what is LV. So then according to thermodynamic laws, kb, what is kb? A molar elevation boiling point. Kb equal to R, wherein R is the ideal gas constant. Its value is 2 calories. So then what is TB naught? TB naught is the boiling point of solvent. What is boiling point of solvent? By 1000 into LV. So then LV is the one of the constant. Now to substitute the Kb value in this reaction. What is Kb value in this reaction? So now what is delta TB equal to what is Kb into M? What is Kb into M? So then what is Kb? R into TB naught by 1000 into LV. Okay, 1000 into LV. So now Kb, what is Kb equal to what is M value? M value is weight by gram molecular weight into 1000 by gram molecular weight, 1000 by weight of the solvent. What is the weight of the solvent? So now it is what is Kb. So then delta TB equal to what is delta TB equal to Kb value. What is Kb value? So then R into TB naught by what is 1000 into LV. So then into what is molality. What is molality? So it is the elevation in boiling point. Elevation in boiling point. So now after completion of the elevation in boiling point, third colligative property is depression in freezing point. What is depression in freezing point? So then depression means the freezing point of solvent is greater than freezing point of the solution. So now third colligative property is depression in freezing point. Depression in freezing point. Okay, depression in freezing point. So now it is explained with one suitable example. For example, let us consider a vessel. Okay, let us consider a vessel. So then pure solvent is taken in the vessel. What is pure solvent is taken in the vessel. So now it is the pure solvent. What is the pure solvent? Now addition of small quantity of non-volatile solute. So then addition of non-volatile. What is non-volatile solute? So then after addition of the non-volatile solute, what happens? The vapor pressure of the solvent decreases. What happens? Vapor pressure of solvent decreases. So for example, solvent vapor pressure. What is solvent vapor pressure is X. So then solute added to the solvent, then solution is obtained. What is solution is obtained. So now vapor pressure of the solution, say Y. So now with respect to vapor pressure, so then X is greater than Y. Same as elevation in boiling point. Now the change in the freezing point. What happens? So first of all, let us consider solvent. So then addition of the non-volatile solute. So then after addition of the non-volatile solute to the solvent, then the freezing point of the solvent is increases. It means solution converted into vapors at low temperatures. What is converted into vapors at low temperatures? It means solution boiling point is less comparatively what is boiling point of the solvent. So now wherein with respect to delta TBF. So wherein F means freezing point. What is F means freezing point? in delta TB equal to what is TB minus TB naught, but wherein delta TF equal to TB F naught minus, or simply what is it is simply denoted with delta TF. What is delta TF? Delta TF equal to what is TF naught minus TF. What is TF naught minus TF? So wherein what is delta TF? It is depression in freezing point. Depression is freezing point equal to freezing point of the pure solvent minus freezing point of the solution. What is the freezing point of the solution? So simply, so then delta TF. What is a delta TF? Delta TF equal to TF naught minus TF. TF naught minus TF. It is the depression in freezing point. So it means after addition of the non-volatile solute at low temperature, solution becomes to vaporization. So then automatically what happens? The freezing point of the solvent increases. What happened? Freezing point of the solvent is increases. So now delta TF is the depression in freezing point. What is the depression in freezing point? TF naught is the freezing point of pure solvent. It is the freezing point of pure solvent. Freezing point of the pure solvent. So then TF is the freezing point of solution. What is the freezing point of solution? So now a graph drawn between freezing points and vapor pressures. What is the freezing points and vapor pressures? Now the graph drawn between freezing points and vapor pressures. So now vapor pressures are taken on the y-axis. So now freezing points. What is simply freezing points? Also temperatures. What are freezing point? Also temperatures. So then temperature is taken on the x-axis. So for example, in this graph from left to right, freezing points what happens? So increases. In this solvent and solution which having less freezing point, solution with less freezing point. So then TF is the what is more freezing point. Solvent is the more freezing point, solution is the less boiling point. So then it is, for example, it is the TF. What is a TF? So for example, it is the TF naught. What is a TF naught? So TF naught is the freezing point of the solvent. What is the freezing point of the solvent? So now it is the freezing point of the solvent. So now it is the freezing point of the what is solute. Freezing point of the